Welcome to Surds Level 5. One step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic by topic playlists on the channel homepage. In problem 1, we're rationalising and simplifying 5 over the square root of 7 minus 3. Now here the denominator has two terms in it, and when we rationalise the denominator that has two terms, we need to multiply by the conjugate of that denominator. And all this means is that we take the original denominator, root 7 minus 3, and just change the sign to make it root 7 plus 3. Now if we're doing this to the bottom of the fraction, we need to also do the same to the top. So we need to multiply the top by root 7 plus 3. And because I'm multiplying by two terms here, we need to make sure that these go in brackets. So focusing first on the numerator, we have 5 multiplied by root 7. This gives us 5 root 7. And then 5 multiplied by 3 gives us plus 15. Moving on to the denominator, we start with root 7 multiplied by root 7, which gives us 7. Root 7 multiplied by 3 gives us plus 3 root 7. Minus 3 multiplied by root 7 gives us minus 3 root 7. And finally, minus 3 multiplied by 3 gives us minus 9. Now we can see that in the denominator, the 3 root 7 and the minus 3 root 7 are going to cancel out. And this is great because it means that the denominator has been rationalised. And this will always happen if we've done this correctly. So our numerator is just 5 root 7 plus 15. And our denominator becomes 7 minus 9, which is minus 2. And it'll be absolutely fine to leave our answer like this, because we can't simplify any further. Having said that, a neater way of writing this fraction is to write it without the minus in the denominator. And so to get rid of this minus, we can multiply the denominator by minus 1, as long as we do exactly the same to the numerator. And if we multiply the denominator by minus 1, the minus 2 just becomes 2. And on the numerator, we're going to get 5 root 7 times minus 1 is minus 5 root 7, and 15 times minus 1 is minus 15. So our final answer to problem 1 is minus 5 root 7 minus 15 all over 2. In problem 2, we're rationalising and simplifying 2 plus root 7 over root 7 plus 1. Again here, to rationalise, what we need to do is times the top and bottom of this fraction by the conjugate of the denominator. And this means that we take the original denominator and we just change the sign. So it becomes root 7 minus 1. And we need to do exactly the same on the numerator to keep the fraction equivalent. And again, I'm going to put each of these pairs into brackets so that when we expand correctly. And if you'd like a bit more help with expanding brackets in general, take a look in the top right corner where you can see my course on expanding brackets. Now back to the problem, starting with the numerator, we have 2 multiplied by root 7, which is 2 root 7. Next, 2 multiplied by minus 1 is minus 2. Root 7 multiplied by root 7 just gives us plus 7, and root 7 multiplied by minus 1 is minus root 7. In the denominator, we can expand in a very similar way. So we have root 7 multiplied by root 7 is just 7. Root 7 multiplied by minus 1 is minus root 7. 1 multiplied by root 7 is plus root 7. And finally, 1 multiplied by minus 1 is just minus 1. Looking at the numerator to start with, we can simplify. So 2 root 7 minus root 7 just gives us root 7, because 2 minus 1 is 1. Next, minus 2 plus 7 is plus 5. So we have root 7 plus 5 in our numerator. In the denominator, the minus root 7 and the plus root 7 will just cancel out. And as mentioned in the last example, this will always happen if we do this correctly. And then we're left with 7 minus 1, which is just 6. Now here, 1, 5 and 6 have no common factors greater than 1, which means that we can't simplify the fraction any further. So root 7 plus 5 over 6 is our final answer to problem 2. In problem 3, we're rationalising and simplifying 2 root 5 minus 4 over root 3 plus root 2. So again here we can multiply the top and bottom of this fraction by the conjugate of the original denominator. And this means that we're going to multiply by root 3, changing the sign in the middle, we have a minus, and then root 2. And doing this will help us rationalise the denominator, which means to get rid of those square roots. If we do that to the bottom, we have to do exactly the same to the top. And to make sure that we expand these correctly, I'm going to put each of these into brackets, and we can now expand. So starting with the numerator, 2 root 5 multiplied by root 3 gives us 2 times, and then root 5 times root 3 just gives us root 15, because 5 times 3 is 15. Next, we have 2 root 5 multiplied by minus root 2. This is going to be minus 2 times, and then root 5 times root 2 is root 10, because 5 times 2 is 10. Next, we have minus 4 times root 3, which is minus 4 root 3. And finally, minus 4 times minus root 2 is plus, because we're multiplying together two negatives, 4 root 2. Doing something very similar in the denominator, we can expand. So we have root 3 times root 3 gives us 3. Root 3 multiplied by minus root 2 is minus root 6, because 3 times 2 is 6. Root 2 times root 3 is plus root 6. And finally, root 2 multiplied by minus root 2 just gives us minus 2. Now on the numerator, none of the surd parts here are the same, and none of them can be simplified any further because we can't find two numbers where one of them is a square number that multiplies to make any of these. So our numerator is going to remain exactly as it was here. So 2 root 15 minus 2 root 10 minus 4 root 3 plus 4 root 2. On our denominator, we can simplify. So here the minus root 6 and the plus root 6 cancel out as expected, and 3 minus 2 just gives us 1. Now we can simplify slightly here by dividing the numerator by 1, and all that does is it keeps the numerator exactly as it was. So our final answer to problem 3 is 2 root 15 minus 2 root 10 minus 4 root 3 plus 4 root 2. In problem 4, we're rationalising and simplifying 2 root 18 plus root 8 all over root 2 minus root 3. Now we could start this in exactly the same way that we have done for the previous 3 examples by multiplying the top and bottom by the conjugate of root 2 minus root 3, which would be root 2 plus root 3. And there's absolutely nothing wrong with starting in this way. Having said that, I can see that on the numerator we've got some surds that can be simplified, because 18 and 8 can both be written as a product of two numbers where one is a square number. So I'm going to start by simplifying these first. So starting with root 18, 18 can be written as 9 times 2, and 9 is a square number, so root 18 can be written as root 9 times root 2, and the square root of 9 is 3. So this becomes 3 root 2. Similarly, 8 can be written as a product of two numbers where one is a square number, because 8 is 4 times 2, and 4 is a square number. So root 8 is the same as root 4 times root 2, and because the square root of 4 is 2, this becomes 2 root 2. So going back to our original fraction, our numerator becomes 2 times, and instead of root 18 we have 3 root 2, plus, and then instead of root 8 we have 2 root 2. And we can see at this stage that our numerator is going to simplify nicely. So starting with 2 times 3 root 2, this just becomes 6 root 2, and we have another plus 2 root 2 afterwards, and our denominator for the time being can't be changed. Now on our numerator, 6 root 2 plus 2 root 2 just gives us 8 root 2. So we have 8 root 2 divided by root 2 minus root 3. And now that our numerator has been completely simplified, we can rationalise. And we're going to do what we mentioned earlier. We're going to times the top and bottom of this fraction by the conjugate of root 2 minus root 3. And that's root 2 plus root 3. And exactly the same on the numerator. And when we multiply, we just have to make sure that these go in brackets so that we multiply correctly. So starting with the numerator, we have 8 root 2 multiplied by root 2. So this gives us 8 times, and then root 2 times root 2 is just 2. So we just get 8 times 2, plus 8 root 2 multiplied by root 3. This gives us 8 multiplied by root 2 times root 3, which gives us root 6, because 2 times 3 is 6. In our denominator, we have root 2 times root 2, which is 2, root 2 times root 3, which is plus root 6, minus root 3 times root 2 is minus root 6, and minus root 3 times root 3 gives us minus 3. So staying on our numerator, 8 times 2 is 16, and we still have a plus 8 root 6. And on the denominator, as expected, the root 6 and the minus root 6 cancel out, and we're just left with 2 minus 3, which gives us minus 1. Now, if we divide each of the terms in the numerator by minus 1, the 16 divided by minus 1 becomes minus 16, and 8 root 6 divided by minus 1 becomes minus 8 root 6. So minus 16 minus 8 root 6 is our final answer to problem 4.